and now move this file over to that read big. Alright, I accidentally clicked on it. I guess after I moved it, it tried to open it and my code editor just crashed. So I had to pause the video for a sec there. So let's try this out. So the source will be text-gigantic, and this is going to be my destination. I'm gonna save, and let's try this. I'm not even sure if it's going to work. I think we are going to crash. So let's see. I'm first going to open up my activity monitor and switch to the memory tab. And now I'm going to run the code. So let's see what is going to happen. So I'm going to run it. That was quite intense, and if you take a look at my memory pressure, it jumped all the way up. I mean, my computer just froze. I couldn't even move my mouse. Hopefully it didn't tamper with my recording. I don't know, maybe it did. I'm going to remove it in the editing later if it did. But you can see that it did not work. So it just crashed. My memory usage really jumped up to 1 GB, and I think it kept going, and my computer just froze. But we managed to copy 7 GB of the data. So definitely not a good option to do it this way. So what I'm going to do right now is to use that draining and try to optimize this code. So here's how we can do it. Now remember we said that this function will return false if our buffer is full. And if it's false, you should never ever write to this stream again. So if it's false, you have to wait for the stream, let it drain, let it empty the buffer, let it do the write, and then you're free to write again. So I'm going to say if this returns false, in my code, I'm going to pause the stream. So I'm going to say stream read dot pause. So if our buffer is full and the stream needs some time to drain itself, while it's happening, I'm going to pause the read stream. So it means that we're not going to get any more data, and we're just going to pause. And I'm going to add the drain event right here. So stream write dot on drain. Now here, what we're going to do is to just simply resume the read stream. So I'm going to say stream read dot resume, and this is another method that we have available on a read stream. So using pause, you could change the mode of your read stream to a paused state. So it's no longer giving you data, it's no longer reading from the source, it's now paused. But when you resume it, it's going to resume. It's going to start from where it was paused and then start to read the data again and give you the chunks. Alright, so now let's try this code and see if we could get the copy successfully. So I'm going to save, I'm going to delete the destination file, and I'm going to run it again. I'm also going to monitor it using my activity monitor. So let's see if we could do it successfully. So I'm going to run it. Now, looks like we're doing the copy. If you take a look, our memory usage is fairly low at only 30 megabytes. And if you go to the disk, you can see that we're writing 90 gigabytes. So it's pretty much done. If it gets to 10, it means that we're done. And yep, we're done. So the process was ended successfully, and we managed to copy the file. Let's also check the file sizes and see if we are getting the right numbers. So my destination is 10 gigabytes and the source is also 10 gigabytes. So we're getting the exact copy. So if you take a look at the bytes, you could see that they have the exact number of bytes. The end is 400 bytes, 411 bytes, and here it's also 411 bytes. So we're not losing even 1 byte in this copy operation. And you can see that it was very, very fast. It only took a couple of seconds, and also our memory usage was extremely low. I think it was only 30 megabytes. I'm not sure if it got higher than 30 megabytes, but it was at that number. way better than that 1 GB of memory usage that we got. My computer just freezed, but now nothing really happens. I mean, if you try to write this code, if you create a file that's like 100 GB in size, so instead of writing a trillion times, maybe write thousands of trillions of times, and then try to do this again, you could just let it happen in the background and then continue on with the rest of your day. So you could let this application run and try to copy a file that's 100 terabytes and then just do your daily things, maybe check the news, check your emails. Nothing is going to be slowed down that much. So this is pretty good, and you could see how streams could be very powerful. Now here we're just dealing with files, but you can imagine that these files could be requests, or they could be messages that you're trying to send to another process, or they could be something that is coming out of your database. So you could really easily deal with huge amounts of data. I mean huge, really, terabytes of data, hundreds of gigabytes, and nothing is really going to be that bad. So actually it's going to be really good. Yeah, that's right, your CPU usage will be 100%, but that's fine, that's what you want. The point is to keep that memory usage as low as you possibly can. Now, with this in place, let's also try to do something a bit fancier. So what I'm going to do is to, as we're reading these chunks, let's try to extract only some values. So let's try to only extract maybe prime numbers or even numbers. And instead of writing the whole chunk, only write those numbers.
So if you take a look at this text gigantic, now I can't open it because my Visual Studio Code is going to crash, but if we try to take a look at the content but using a stream, so what we can do is to just try to open this file, but just like a stream, just like what we did. So we need to move one portion at a time into our memory. Now if you use the cat command, it's just like that. It's going to open a file but using a stream. So I'm going to say cat text gigantic just to take a look at some of the numbers that we have. And as you can see, my computer is not crashed, I'm not slowing down, it's just everything is just working as normal, and this application is also working for itself in the background. So we're moving one chunk at a time in our memory and then logging it, so we're not having any memory issues here. Whereas if we try to open it using Visual Studio Code, it's going to crash because it's going to move it all into your memory, and that is not really going to work in this case because the file is huge. Now I'm going to hit Control-C and stop this process, and as you can see, we have quite a lot of numbers. Well, we have 1 billion numbers here, and we counted until 100 million, around 100 million. So what we need to do is to just read them just like here, one chunk at a time, but only extract even numbers. Only write these even numbers to our destination. So we don't care about odd numbers, and we're going to dismiss them. We only care about even numbers, and the way we can find out if number is even or not, you just get the remainder by 2. If it's 0, it's even, otherwise it's odd. So the total number of numbers that we're going to have in this dest file, which will only have even numbers, is going to be, I think, 1 billion divided by 2, because we have an even number every other number, right? So if you divide all the numbers by 2, you should get how many even numbers you should have. So let's try this out. So I'm going to first, well, let's first log the chunk and convert it into a string. So these chunks are now in zeros and ones, so I'm going to first convert them into a string using a character encoding. So I'm going to say chunk.toString, and the character encoding that I'm going to use is UTF-8, which is by default, but I'm going to specify it nonetheless. And UTF-8 means that each character will be represented using only 8 bits. So each one of these characters, maybe a 3, maybe a space, maybe another space, maybe a tab, or maybe a new line character, they will all be represented using only 8 bits. So 8 zeros and ones, like this. So each character corresponds to this many bits, which is 8 bits. So I'm going to first convert it into this, and also I'm going to split by a space, because I want to convert each chunk into an array and have each number as its own individual element. So I'm going to say .split space, and the way split works is like this. So let me show it to you pretty quick. So if I create an array, so let array equals, actually I first have to create a string, equals maybe 1, 2, 3, 4, 5, and if I say str.split, and you could split by any character that you want. If we split by comma, we're gonna get an array 1, 2, 3, 4, 5. We also have some spaces here which we need to count for. Now you could remove these spaces by something like this. So if you say maybe string equals a space and then a number and then another couple of space and then end. Now if you just run the trim function on it like so, it's going to remove all the spaces before and after it. So we're going to use these two methods to populate our array. So I'm going to first split by this y space, and let's just log this and see if we are getting the right number. So I'm going to say const numbers equals this and just log numbers. All right. Now I'm going to run this code. Alright, so we're going to need all the numbers, but let's just hit Control C and exit because we don't need to take a look at all of them. But now, as you can see, it's not really working as expected. We've got some of these empty spaces, and I mean, what does this do here? So it's not really working as we want it. And if you take a look here, well, all these numbers are correct, right? But the number that starts at the beginning of each array is not really correct. So let's first try to account for these empty strings. Let's see what's going to happen if we try to split by 2 spaces. I think, yeah, now we're getting the numbers correctly. Because if you open the file, we are using 2 spaces to separate the numbers, not 1. That's my mistake. So we should split by 2 spaces and not 1. If we take a look at the right many functions, we're putting 1 space and then another space and then our number. So the next number will have another space at the beginning and then its whole number. And each character, so 1 character, and this number is going to be a couple characters, and then 1 character at the end is going to be represented using 8 bits or 1 byte. So 8 bits is equal to 1 byte. Alright, so now we have our numbers, but notice again that still we have some problems here at the beginning of some of the arrays. Here we have a 0, which is definitely not expected. Let me also take a look at the first array. So I'm going to run and quickly exit. And nope, we couldn't get it. But you could see that all the first elements are not correct. So we need to somehow fix these first numbers. So if we do that, if we fix the first elements of all these arrays, or maybe possibly the last elements, because we can't take a look here, right? And we could try to log it by saying numbers, so numbers dot length -1, and this way we could take a look at all the numbers. So let's also try to log them like this. So these numbers should be in order. If not, it means that we have a problem. And as you can see, we definitely have a problem, and it's not really expected. Okay, so this is the one element before the last element of our array, and this is our last element, right? And as you can see, all the last elements, well, this one is correct, but most of them are not correct. So if we could fix this and somehow get our first elements and last elements correctly, then what we're going to end up with is an array of all the numbers that we need, right? And then all we need to do is to just loop through each array, extract these values, convert them to a number, and then check whether or not they're even. If they are, we're going to write them to our stream. If not, we're just going to dismiss them. So let's first try to fix this issue with these starting and ending numbers.
So let me now jump into my whiteboard and show you what is really happening here. Alright, so we're getting our numbers in this format. So we have our first array, and our first number is 0, goes 1, 2, 3, and all the way to a last number, which we could calculate if we wanted to, because we have the size of our buffer, and we also know that each character is represented using 8 bits, so we could calculate what the last number would be. But I'm just going to say something randomly, so maybe 32,000 and then 182. But notice that this will not be the case because we're getting the data in chunks. So we could maybe get the first two digits, first two characters, maybe we could get 32, and then we're not going to get the 8182. We're going to get that in the next chunk, right? So we're going to have a problem here. And if you take a look at the next array, now this next array, because we didn't get the last 3 digits in the first array, we're going to get it right here. So we're going to lose some digits, and we're going to get 182, and then we're going to move forward with our array. And also here we have a problem because we have some lost characters. So the last element of this array also is going to be maybe 62,000 and then some lost characters. So we're going to have a problem here as well. And then next array, just like before, we're going to have a problem at the beginning and also at the end. Now, we could also not have a problem. We could get the last number, but completely complete and without any lost characters. But notice that it will rarely happen. In a lot of cases, we're going to have some lost digits at the end of the last elements of an array, and also at the beginning of the first elements of an array, like here and like here. Now, the last array, our first element again is going to have some lost digits, and we're going to have a problem here. But for the last element, we're not going to have a problem, right? So imagine that we're dealing with that first file that was 7.9 megabytes, and our last number was 6 nines, so we were writing 1 million times. Now, the last array is not going to have any problems, right? Because we're not splitting, we're just getting all of the end of the data in just one chunk. So our last element is just going to be completely okay. Just like the first elements of our first array that is completely okay, the last elements also of our last array is totally fine, and we don't have to do anything about it. So what we need to do is to somehow manage these missing characters. Now, one thing that we can do is to just get the last element of the chunk that we're dealing with, and then append this last part to the first elements of the next chunk that we're going to get. And we're going to see how we can do this. Now, to really understand why we can do this and how actually we can do this, let's first try to talk a little bit about binary. So keep this in mind, all right? Just gonna put it here at the right bottom of my screen. Now, let's say that this is our file. That first file was 7.9 megabytes, and we were writing 1 million times. So we have a huge amount of data here. Now, if you get the file size, it is 7.9 megabytes, right? And if you get the exact file size, if you just right click and click on get info or properties if you're on Windows, or any other way that you can get the exact file size. Now I have it opened up on my Mac right here. So it's 7,892 and then 693 bytes. So this is exactly how many bytes we have in our file. Now, if you multiply this number by 8, you're going to get the number of but in bits. So if you do the calculation, so 7,892, 693 times 8, you're going to get the number but in bits, because 1 byte is 8 bits. So the number is roughly around 63 million. I'm not going to write all the number, but I'm just going to say roughly 63 million bits. Alright, so we have around 63 zeros and ones in this file right here, in our file that we created. Now let me just say this because I know some of you might just forget it. So 1 byte is equal to 8 bits, right? And also, each hexadecimal character is represented using 4 bits. So I'm just going to put down 4 zeros. Now it could be 4 zeros or 4 ones or any combination of that, but one hexadecimal number is equal to 4 bits. Each hexadecimal number is representing 4 bits. Now, the character encoding that we're using is UTF-8. Now, this 8 here means that we're representing each character using 8 bits. So, UTF-8 means each character, so one character is representing using only 8 bits. So we could have 8 zeros and ones. Now I'm just going to again put down 8 zeros, but it could be 8 zeros or ones or any combination of that again. So also keep this in mind. I'm just going to put it right here. All right. So now, the important point to take here is let's take a look at one JavaScript array. So let's say that this is our array. We have 1, 2, 3, and that's it. So this is our first index, which is 0, and our second element, which its index is 1, and then the last element, which its index is 2. So this is a typical array. Now, a buffer is just like this. Now, a buffer is a unit 8 array. It's a subclass of a unit 8 array. It means that if it is our buffer, each element of our buffer holds 8 bits. I'm just going to put down 8 zeros. So this is our first element of our buffer. And then the second element is just like before. Now, in this case, I'm just going to say maybe 0, 0, 1 or 0, 0, 1, 0. So let's say that we have a buffer that only holds 2 elements. So it only has 16 bits or 2 bytes. So here we have a 2-byte array. Now the chunks that we're getting are 64 kilobytes or 64,000 bytes. All right, so 64, I don't remember what the number was exactly, but I'm just going to say 64,000 bytes. So we're getting the chunks and these values. But let's say that we have a buffer that is only 2 bytes, right? So say we only have this buffer, and let's see how this buffer is representing our data. So as we said, each element of the buffer holds 8 bits. So this is our first index, or our 0 index, and this is our 1 index. So index 1 corresponds to the second element, index 0 corresponds to the first element. Now, if you try to log the buffer in, you're not going to get the values like this in zeros and ones. For the sake of simplicity and so that you could easily look at the data, they are represented using hexadecimal numbers. And we said before that each hexadecimal character represents 4 bits. So this 4 will be 0, 0 because we have 8 zeros, and each one of these will be a 0 in hexadecimal numbers. Now the first one is quite different. So this number, if you do it on a calculator, on a programming calculator, you're going to get 1 and then 2. So this is how you will see the buffer if you try to log it onto your screen. Now you could do these conversions using a programming calculator or just using math. If you learn how to do it using math, I guess it'll improve your understanding of binary numbers and binary data and all of this stuff, but you don't really have to. You could just use a programming calculator and the rest will be easy. Right, so this is how we are getting our buffers. Now, I want you to really notice something here. We are getting data in different buffers, and these buffers have this much size. So we're doing some splittings, but we're not doing the splits maybe at here, right? This does not work. We're splitting maybe at here or maybe at here. Now if we take a look at our array, we cannot split at half of 1. This doesn't work, right? It just doesn't make sense. You cannot say split my array at index 1.5, right? You can't say that. You could just split at concrete numbers. Maybe you could split at 0, you could split at 1, you could split at 2. You cannot split at 2.5. Same is exactly true when you're dealing with buffers. You could split at index 0 or index 1, but you cannot split at maybe 1.5. So you cannot get one of this elements in one buffer and then another one in another buffer. If you convert this into a unit 4 array and make it so that each element of the buffer represents only 4 bits rather than 8 bits, then you can do that. You can split at maybe here. But you first have to convert it into a 4-bit array like this, and then you could do those splits, right? So here, this is a unit 4, meaning that each element of this buffer is represented using only 4 bits. But here it's a unit 8 array. It means that each element of the buffer is represented using 8 bits. Now, something to keep in mind here is we talked about this UTF-8, and we said that in UTF-8, each character is 8 bits. Now, what's really neat here is that in our buffer, because each element holds 8 bits, it means that each element of our buffer corresponds to one character, right? So in UTF-8, you can have maybe any characters, really. You can have numbers, so 1, 2, so many numbers, and you can have letters, so maybe A, B, you could have them capitalized or lowercase, it doesn't matter. So many different characters, millions of characters, and also you could hold some special characters, like maybe a space, or a new line character, or a tab character. So if you put this character in your file, it indicates that you need to go to the next line. It's just like an enter. So if you hit enter in your text editor, you're actually putting a new character into your file. And your text editor will not show slash and then n, it will just show a new line. But again, the neat thing is that each character, now in our file we only have letters and spaces, but each one of these are held in one element of a buffer. So when we are splitting and we're getting the data in different chunks, we are splitting by characters. So if this is maybe one element, if we are at this point, maybe 22, and then 3, 4, and then some numbers before it and after it, we cannot split this 3 in half. It just doesn't work. But we could split at this location, and we could split at this location as well. So I really want to make this extra clear that you cannot split maybe 4 in half. You could have done this if you were representing a buffer using 4 bits rather than 8 bits, and then you were using UTF-8. Then in that case, well, sure, you could maybe do something to get half of the data of this character in one buffer and then half in another buffer, which is really unpractical, and then you would have to do a lot of work to add these numbers together. But because we're representing each character using only 8 bits and we're using UTF-8, each element of our buffer is only one character, and we're splitting at elements, just like an array. We cannot split at half of an index or a quarter of an index. We're just splitting at each index. Alright, so now that we know this, let's take a look back again at our array. Let me also erase these, and let me try to make it a bit bigger. Alright, so what we need to do is to first find out where we have a split. So here we have a split. So what we want to do is to put the split in a variable. So maybe we could define a variable called split and save that variable in it. So in this case, it's going to be 32. We're not getting 182, we're getting it in our next chunk. And then when we are moving to our next array, so we're getting the next chunk, we check whether or not this number is correct. And we could do that by adding 1 to it. And if we add 1 to it, we're going to get the next element. If we get the next element, it means that we're not having any splitting issues. We're getting the number completely. But if we add 1 to it and we don't get the next element, it means that we have a split issue. So what we're going to do is we're going to take this 182. This is the first element of that our second chunk. So 182, and we're going to add that split value to it, which is 32. And we're going to do this in a string and not a number, right? So we're going to get 32182. So we're going to get our complete number. So this is what we have to do. We have to check the end of the arrays if they're not complete, and then if we subtract 1 from the end of the elements, if we subtract 1 and get the element before it, it means that we are not having a splitting issue. But if we subtract 1 and we don't get the elements 1 after it, before it, it means that we have a splitting issue. So we have to save the last elements in a variable, maybe called split, and then in our next array do the check and see if we are having a splitting issue. If we do, we're just going to add these two numbers together and we're going to get the correct number. So this is how we can deal with those numbers that are not complete. This is how we can attach them together and then get the right numbers. And then when we do get the right numbers, we're just going to convert them into a number and then do our checks. Maybe check whether or not the number is even and then write it, or maybe check if the number is prime, or anything. We could just do anything that we want. But the point is we're getting the numbers as we want them. All right, so let's now implement this in code. So what we can do is to just do a quick check. So I'm going to remove these lines, and right here I want to say if the last number is not equal to the number before it in each chunk that we get, it means that we're having a splitting issue. So if numbers at length -2, now this will give us the last number before the last element of an array. So if I add 1 to it, and if I don't get the last number, numbers.length minus 1, now if this returns false, then it means that we're having a splitting issue. Or if it returns true, actually, because we're doing not equal. Now, these numbers that we're getting are actually strings, so we need to convert them to a number as well. So like this. You could just use this number constructor to convert any string into a number. So if I say number, maybe this string, it's going to give me a number. So if I add 1 to it, it's going to be this. If we just try to do the same thing but define a string, and you try to add 1 to the string, it's not going to work. You're just appending 1 at the end of the string. But if you first convert it into a number and then add 1, you're adding it to that number, but you know, correct math. So if it is the case, what we're going to do is we're going to pop the last element. So we're going to remove the last element of our current chunk and save it into a variable. So I'm going to define a variable here, and I'm going to call it split. It's going to be initialized to an empty string. Now, if this is the case, I'm going to say split equals numbers.pop. Now, if you run this .pop method will remove the last element of an array. If this is our array 1, 2, 3. If I say array.pop, it's going to give me the last element, and it's also going to remove that last element off of that array. So I'm going to use this method to remove that last element and save it into my split variable. Alright, so now using this, we're taking care of the last elements. Now let's take care of the first element. So I want to say if numbers, the first element of the number is not equal to the element after it -1, so numbers 1 minus 1, if this is not the case, and I also need to convert them into a number like this, Now if this is not the case, we want to do a check. So if we do have our split from the previous chunk, we're just going to say that numbers, the first element of our array, we're just going to replace it with our split. And I'm also going to run the trim function on it. So with our split plus the first number. And also the trim function. We might not need it, but just in case. So now at this point, we have our numbers exactly as we need them. So let's just try to log the numbers. So log numbers. So, and actually we're not getting the numbers correctly, and well, it's because we need to change the order of these two if statements. So we need to cut this and paste it here. So because we're checking the splits from the previous chunk and not the current chunk, so if I put this after this if statement, what's going to happen is that I'm going to update the splits with that current chunk, which is not something that we want. We want to check the split from our previous run, and if that's the case, we're going to do our splitting. Actually, we're just going to add them together and replace the first elements. Now, let's try it again. And now in this case, we are getting the arrays correctly. And as you can see, this number is exactly one before the next number. Now also notice that here we have a space, but we're doing the trimming. Now, these cases are because the numbers are correct in the first place. So we're not doing this check. So this will not return. We're not getting to this point, and therefore we're not really adding anything to them because they are already correct and we don't have to correct them. But these numbers are the ones that we have actually corrected. So here we have another space. It means that this number was correct before we even got to that point. Alright, now let's also try to take a look at the last two elements and see if they are correct. And I guess these trims are redundant. If that's the case, it would be better to remove them because we're doing 2 less operations and we're also dealing with a huge amount of data, so doing 2 less operations could save us some good amount of time. So I leave this up to you to figure out whether or not these trims are redundant or not. If they're redundant, just remove them, we don't need them, but I'm going to leave them just in case. Alright, so now our numbers are exactly correct. So what we can do at this point is to just loop over these numbers and only write the even ones out to our stream. So let's try to do that. So I'm going to say numbers.forEach, and this for each will run, and in the callback we're going to get each number. So I'm going to first convert the number into a number because this number is now a string. If you take a look, this is a string, so we have to convert it into a JavaScript number first, and we can do that using this number. So number, lots of numbers. Hope I don't say number another time. Now we say if n, if its remainder by 2 is equal to 0, it means that it's an odd number. Actually, it means that it's an even number. So we're going to write that to this string. So I'm going to cut this and paste it here. Now, rather than trying to write the whole chunk, we write space plus n plus another space. And if it returns false, it means that we need to drain. So we're going to stop reading from our stream and then let it drain. And then once the draining is done, we're going to resume reading again from that file. So let's try this. So I'm going to, well, actually, let's try it with a very simple file because we're going to need to open it and check it out. So I'm going to switch to that right folder, and instead of writing a billion times, actually I had already done it before I recorded this portion of the video, but you could go on ahead and do it and change this number to 1,000,000 and then run it, and then you're going to get this test.txt file, which just like before should start from 0 and ends at 6 nines. So let's try to copy this file and paste it in our readbeg folder, and let's go with that file. So instead of reading the whole text gigantic, I'm just going to read the normal text. The name is test, so let's change it to text dash small. So text dash small. So this is our big file, very big file, 10 gigabytes, and this is our tiny file, only 7 megabytes. So let's run this and then check our destination des.txt file and see if we are getting all the even numbers out. So I'm gonna run the code, node readbeg, and it took a second. And let's now take a look at our des.txt file. And as you can see here, we're getting all the even numbers. And I doubt that we are missing even one number. So we're getting all the numbers. The last numbers should be 5 9s and then an 8. And yep, we get the number, and then one before it is the even number before this number, and so on and so forth. Now the file size should be roughly half of the text small file, which is actually the case. So this is, if you round it up, it's 4 megabytes, and if you round this up, it's 8 megabytes. So it's half the size of this text small. So we're getting the even numbers correctly. Cool. Now if you want, you could also just get the numbers that are divisible by 10, just like this. Run it again. We'll run pretty quick, and our destination, we're getting all the numbers that are divisible by 10, meaning they have a 0 at the end of them. Alright, perfect. So this code is now working pretty good. Now this isn't the testing that you should do. If you want to do this, just don't try to look at it and say, okay, it looks good, so the code works fine. You gotta do some testing. So maybe try to go over this file one element at a time and then add 10 to each one of them. You should get the next element. And if you don't, it means that we are missing a number, or maybe something else, or maybe we have some logic errors. So I encourage you to, whenever you're doing this in production and you want to ship something to the real users, really try to do so many testing. Don't leave your code up and say, all right, it looks fine, and that's it, I'm gonna go with this. Absolutely not. You should do some rigorous testing and really make sure that you are getting the right numbers. Now we're not going to do this in this video, but if you want, you can do that. And for example, if we were getting the even numbers, just get each number, add 2 to it, and then you should get the next element. Alright, so now we're pretty much done with a readable stream. You could just get the data in chunks, and then you could process the data and then maybe write it or just read it. It's up to you. Now instead of just reading it, we could have, maybe added to our database or something like that. It's really up to what you want to do. The point is, you could read a huge file, and if you try to do this with that text gigantic, it will work with no issues. In fact, let's give it one more shot. So text gigantic, and if I run it, now it will take a while because we're doing some operations here. Now this is where I told you, if you try to optimize your code, maybe remove these trims or anything else, maybe find something that you could convert numbers that's faster than this number constructor. Now I don't know if there is one. I tried one of them, and this one came out to be the fastest, but there might be some ones that are even faster. So if you could just optimize this code maybe a little bit, it will really add up and become something pretty big. You could save maybe minutes, seconds. It could be a huge time saver if you just try to optimize even a couple of microseconds or milliseconds. It's really going to be a lot. But if you take a look at the activity monitor, you can see that our memory is only 50 megabytes. So we're doing a whole lot of operations. Not a whole lot, this isn't really a lot, but we're doing some operations and we're doing a lot of readings and writings. So if you go to disk, you could see that bytes read is 8 gigabytes and bytes write is 800. Now, if this bytes read gets to 10, we are done because our file is 10 gigabytes. So I guess I have to wait just a couple more seconds, and that's it. But the point is, our memory is pretty good, only 50 megabytes, and we're reading a file that's 10 gigabytes, and I guess we're done now. Yep, we're done. So if you take a look at the console, we're done with no errors whatsoever. Now if you want, you could time your code, and the way you can do it, is to, well, there's no way for us to figure out our last write. Well, technically we can, but what we can do that's quite a bit better is to try to add an end event on our read stream. So this will happen when we're done reading. So I'm just going to log and say done reading. So first let's take a look at our destination file and see if all the numbers are even. So I'm going to say cat des.txt, and let's stop it right now. So, and as you can see, we are getting all the numbers correctly. Now in this case we are getting the numbers that are divisible by 10, but you could change it to any other number. You could get the even numbers, odd numbers, anything. It's all up to you. But if you just take each number and add 10 to it, you should get the next number, or vice versa. If you take each number and subtract 10 from it, you should get the number before it. So yeah, it looks like it's working pretty good, and the size is roughly 1/10 of the size of our gigantic file. So it's 10 gigabytes and this one is 1 gigabyte. Perfect. Now let's try to time our code and see how long it takes. So right here I'm going to say console.time read big, and here I'm going to say console.time and read big. And I'm also going to read from text small because I have to wait for possibly a minute for it to finish, but this one is quite fast. So node read big. Oops, an error. String read is not a function. Yep, I forgot to call the dot end. Let's try it again. And cool. So it's done reading, and read big took 100 milliseconds. So this is also a good thing to keep in mind. Now notice that in a readable stream we used the finish event, but we don't have access to this one on a read stream. In a read stream we instead have an end event. Now you could get to this point, the finish event, by calling write stream.end. So stream write.end, and when you call this, then you're going to indicate the stream is finished, and then you're going to get to this point. Now in a readable stream, this is not something that you can do. It's automatically done for you. So when the readable stream is done, so it will figure out whether or not it's done, and if it's done, it will automatically emit this end event for you. Now if you're trying to implement a readable stream, which is something that we're going to get into in a couple minutes, when you try that, the way is that if you push a null character to your readable stream, so say stream read.push null, that indicates that your stream is done, which is something that we're going to get into in just a little bit. But yeah, at this point, I have to say that we're pretty much done with API consumers. Let's take a look at the documentation again and go over what we have. So here I'm going to find the readable section. So we're done with the writable, if I can find it. This is all about writable, and here it is, readable streams. Now here again you could see some of the examples. Again, they're just like before, HTTP, but they are different. For example, in the previous writable it was FS write stream, but now it's FS read stream. Same is true with HTTP requests. For example, here HTTP responses on the client. Now a writable stream, it will be HTTP responses on the server. So there are some things back and forth, but you get the idea. Now here it says that we have two reading modes, which is really important to understand. One is flowing and one is paused. Now we did just this. We started to make our stream into flowing mode by adding that data event, and then we paused it when we were draining, and then we resumed it again when we were done draining. And here you could see that it says all readable streams begin in paused mode, but can be switched to flowing mode if you do one of these. So if you add a data event handler, if you call the stream.resume method, or if you call the stream.pipe method. Now we're going to get into pipe in just a minute, but keep that in mind. And then you could also switch back to paused mode by calling stream.pause, or by removing all the destinations. Now we could get these states by calling readable.readable flowing, You can see that if it's null, it means that you haven't done anything. If it's false, it means it's in paused mode, and if it's true, it means that it's flowing. I hope I was right. I don't quite remember, but I think that was the case. Yeah, it says when readable flowing is null, no mechanism for consuming data is provided. So if you just create the stream and you try to log this, you're going to get null. But if you start to make it into a flowing mode by adding a data event, you will change it to true. And when you pause it, it will be changed to false. Now here also says that you should choose only one API style. Now there are two ways to read. One is to add the data event, and another one is to add the readable event and then read by calling a read function, which is not something we're going to get into in this video, but you could read that here in the documentation. And if you understand this data event, this one is just like this one. You will understand it. Then we have some events like the close events, which is kind of like before that close events for the writable. Then we have the data events, which we talked about in great detail. Now you're going to get a chunk, which is going to be a buffer, but if you specify the set encoding, you could also get strings. We have the end event, which is emitted when there's no more data to be consumed from the stream. And the end event will not be emitted unless the data is completely consumed. And here it says sometimes that you are done with the data, but there's still data, you're not going to get into the end. Now sometimes you might just read a portion, do some work with that, and then you're done. But this event will not be emitted. If you want to get into this emit end event, what you need to do is to just switch it to flowing mode until all the data is done, and then you're going to get into the end event. Now you could use this function if you add that readable event on your readable stream. We have the error event, we have the paused event, which will be emitted when you call that pause method. Now this is that readable event, which is just like that data event. Now we should only stick with one. If you are going to use this readable, you shouldn't use the data event again on this stream. Just stick with one. Now the way that you can use this one is to add the event listener first, and then here's how you could read from it. And you could also optionally specify a size parameter to this read function. And here it says that if you use both of them, this one will take precedence and flowing, but you shouldn't really try to do this. Just stick with one. And he also talks about what will happen if you remove these listeners. The resume events, destroy. Now here we have some properties. Closed, which is true if the close event was emitted. Is paused is another method. It's kind of like that variable we talked about, but it only indicates if it's paused or not. This is how we can pause a stream. We talked about this one. Now piping, well, we're going to get into it in just a minute. Now piping is just like that first thing that we did. Now before we add these operations, what we did was that we just copied the stream over, right? So we read from that text and we wrote to that destination. And we also took care of some draining things. So we paused the stream when we were draining, and we made sure that we're not having any memory issues. Now piping is just like that. You add a pipe to a readable stream and then you specify a destination. And Node.js itself will handle all that draining and pausing and resuming for you. We're going to see an example about this piping in just a minute, but that's basically what it does. And this read is if you add this readable event, then you can make use of it and specify a size option. And we also have this property, which is true if it's safe to call this, which means that the stream was not destroyed or emitted error or end. And we also have some experimental methods here. We're not going to talk about them, but if you want, read them and use them. Readable encoding. This will give you the encoding if you call that set encoding function. Readable error, flowing. Now readable high watermark value, which is how you can get that the size of that internal buffer. And unpipe, so you could pipe and then maybe after a while you could unpipe. Now shifting, we're not really going to talk about it because instead you could just use a transform stream, and it's usually better. So let's skip this one, wrap again. We're not going to use this. Now here it says it will rarely be necessary to use reloaded wrap, but we still have it to make it more compatible with older Node.js applications. And then again, some more experimental methods. I encourage you to use them, but we're not really going to talk about them because they could change and they're right now experimental, but they're really easy to understand. For example, using this map, it's kind of like mapping on arrays, so you could map over your readable streams and see what you have. And you can filter, again, like an array for each, and to array, you could convert it into an array, and a couple more. So still more experimental methods. Reduce, and we're done. So we're pretty much done with a readable stream, and then we have to talk about duplex and transform. But let me first show you an example of piping. So I'm going to create a new directory, and I'm going to call it, actually right here, so new folder, and I'm going to call it copy. So here we're going to try to copy a file from one source to a destination. So I'm going to create a new file called copy.js. Now let's also try to put a file here to copy. Now this one is quite small. Maybe let's try to make this test a bit bigger. So actually I'm just going to copy this text gigantic over to my copy folder. Now let's try to copy this. Did I paste it? Come on. Copy and paste. Well, looks like it'll take a while, so I'll wait. Right, so looks like it's done. It tried to open it, but it can't. So now let's try to do something. Let's try to copy this file to a new destination, maybe in the same folder, but change the name to text gigantic-copy or something like that. Let's try to copy the file, but without using streams. So let's try to put aside all these stream concepts that we learned about for just a second and try to copy the file with the current knowledge that we have from the previous videos. So we know how to read a file, and we also know how to write to a file. So we could technically be able to copy this file over. So if you want, pause the video right now and write some solutions, write some code and try to copy this file. And please don't use fs.copy, because if you use this one, it's just going to copy the file using a stream for you. So without using a stream, let's see how we can copy this file. So I'm going to first include the fs module. Require node fs/promises. This function. So I'm going to first read the content of this file and then write it to a destination. So let's first open a destination. So const dest file equals await fs.open. I want to call it text-copy.txt, and I want to flag it as W to indicate that we're going to write. Now I'm going to read the content of this file, so I'm going to say const result equals await fs.read file, and I'm going to use this function now. Now this function will automatically open the file first for you and then return all the contents in one buffer. So read file, going to specify my source, which is text-gigantic, and now this is going to be a buffer. Let's first try it with a very small file. So this one is fairly simple, so it's only 70 megabytes. So let's first try it with the text.txt file and not that text gigantic. So I'm going to change it to text.txt. All right, let's now log the results. Switch to copy and run the application. Oh, not again. My semicolon. All right, there we go. No such file or directory. I don't know what's happening here. Oh, it's test. So let me rename it to text. Alright, so as you can see here, when you call this function, it's going to return all the value in one simple buffer. Now we could specify an encoding if you want, but well, let's just deal with this buffer first. Now what you can do is to just say dest file dot write and then specify that buffer, and that's it. Now this is also a promise, so I'm going to say wait, and our text copy is now empty, but if you run the code, you will now get the data in the text copy. So this is one way you could copy a file over, but it's not really practical. It's actually not practical at all. If you're dealing with very tiny files, it's okay, you could do it this way. But still, even in that way, if you use streams, it's way better. And not just streams, this is really problematic with big files. So let's try to copy the text gigantic file. So I'm going to say text dash gigantic, and I think it's going to crash. I doubt it's going to work. So node gigantic. Now this will definitely crash because we're trying to move a buffer that is just copy that is 10 GB in size, so definitely we're not going to be able to do it. But let's take a look, and as you can see, well, actually we're not crashing. So node is returning an error that says the file size is greater than 2 GB. So it's figuring that out for you, but well, the point is, if you try to do it with a file that's less than 2 GB, what's going to happen is that your memory usage will be the size of that file, which is not really good. So if we just add in 2 here and run this code. So write mini and then node write mini. Alright, it's done, and it took 27 seconds. So let's try to copy this one. I'm going to reveal this in my Finder. Well, it's 1 GB, so we should be okay. So I'm going to paste it here in copy and change the name to just text dash, maybe not small, but to maybe text dash big. Alright, so let's try to copy this text big and see if we can do it. So text gigantic, text big, and we should be able to copy it, but let's also add a set interval function just so that my process doesn't exit. So interval, come on, interval, and I'm just gonna run it every second. And let's open up the activity monitor and check this one. So node copy, and well, you can see that our memory usage is around 900 MB, and it's still doing the copy operation. Actually, I think it's done with the copying operation. It's not exiting because we have the set interval function. But you saw that our code was really bad. Our memory usage was at 1 GB. Now let's also try to time it. So console.time copy, one right here and one right here. So console.time and copy, and I'm just going to remove the set interval because we already know how much memory usage we're going to have. So I'm going to run it. So the copy operation was pretty fast, only at 900 milliseconds, but our memory usage is really high. We can't deal with that. Plus, we can't even copy a file if it's over 2 GB. So what we can do, so let me just add in some comments here. Memory usage is around 1 GB, and notice we can, now we could also add our CPU usage, but this is not how we usually do it, because when you're running an algorithm, a solution, or any code, your CPU usage will be at 100%. So adding CPU usage 100% is pretty useless. Now what we do usually is to report our speed complexity. Now we have 2 things to benchmark our algorithm and our code. One is speed complexity and another one is space complexity. Now space means how much memory your code is taking. Speed means how fast your code can do that operation. Now these are usually topics of algorithms and data structures, so I'm not really going to go over them. But in speed, the way that we report a code is like this. So we say it's big O, maybe n. And if it's big O n, it means that if we have an array of 100,000 elements, we're going to do 100,000 operations. Now if we say it's big O of n squared, it means that if we have an array that has 100 elements in it, we're going to do 100 to the power of 2 operations. So if you learn about these, you're really going to improve your programming skills. So I highly recommend you to learn about algorithms and data structures if you haven't already. There are some great algorithms out there to learn about. It's not just all about interview questions. It's really all about how good you could code, you know, how fast your solutions are, how well they run, and things like that. So definitely learn about algorithms and data structures. They're really important. Every software engineer out there needs to know about these. They will really teach you how to create highly performant code and how to really try to make your code as fast as possible. So definitely keep that in mind. If you haven't already, just go ahead and check out. There are great courses out there, great videos, tutorials, books. Learn about algorithms and data structures. So I'm not going to put my CPU usage here because it's definitely going to be 100%, but I'm just going to say execution time, which was around 900 milliseconds. Okay, now again, let's try to improve this code, but still not using streams. So let's try to come up with our own streaming solution. Let's try to use streams without using Node.js streams. So the way we can do it is to create a buffer and keep filling it and keep writing it. So that's something that we can do to really improve our memory usage. So let's try that out. So I'm going to actually just copy the code out and comment this portion, and let's start from scratch. So I'm going to first get my source file, which is going to be wait fs.open text-big.txt, and we're going to read from this. And I'm also going to create my destination file, which is a file that I'm going to write to. So it means that I'm going to copy from this location to that location. So fs.open text-copy.txt. The flag should be W. So the way that we can do this copy operation is by calling this function source file.read. Now this function will return a small amount of buffer. It will return us a chunk. So let's try to log it. It also returns a promise, so I'm going to wait, and let's run it. So as you can see here, we're getting a value. Now this would look familiar to, it's 16 kilobytes. So this function is returning a chunk of our file. It's not returning the whole file like here. This read file is returning the whole file in just one buffer, and if it's more than 2 gigabytes, it's not going to work. But this will definitely work if I just try it with text gigantic. It will work no problem. But it will only return me a small chunk, a buffer that has a size 16 kilobytes. So what we can do is to just keep executing this function and keep writing the result, the chunks that this will return, to our destination file. And we basically are setting up a stream of our own. So let's try this out. So I'm going to save this into a variable. So I'm going to say const read result equals this. And I'm also going to get the bytes read out of it, equals read results dot bytes read, or bytes read. Now I'm going to check and see, while this is not 0, just keep reading and keep writing to our destination. Because notice now, this is how many we read. Now when we get to the end of the file, it's going to be 0, which indicates that we're done reading and there's nothing else to read. So I'm going to wrap this code inside of a while loop and say while bytes read is not equal to 0, just keep reading and keep writing. And I have to well, define this right here. So bytes read. Maybe I say -1, because when we were starting out, we haven't read anything. So I'm just going to specify it as -1. And right here, I'm going to say let bytes read equals that result. So while it's not 0, we're going to keep reading. And then what we can do is just write this buffer into our destination file. So des file.write read result, well, it was called buffer. So we're going to get the buffer out of it and write it to that location. All right. So this is how we can actually set up our own stream. Now, notice that if you're doing this in production, definitely take care of all the error handlings, wrap it around the try catch, and handle the errors. We're not going to do it in this video for the sake of teaching and simplicity, but in production, definitely always wrap your code around the try catch whenever you're using this await and handle all the errors. So let's try this code, but using text. First, let's try it with text-.txt, a small file. It gets sometimes confusing, so text.txt, this is our small file, right? Yeah, it is. I want to change the name to text-small. Okay, so this is our 7 megabytes file, this textbook is our 1 gigabyte file, and this gigantic is our 10 gigabytes file. So I'm going to say text-small. So let's try to copy this. Alright, looks like it was successful. If I take a look, well, you see some weird characters here, some nulls, but apart from this one, the copy was successful, as you can see. Now, the reason that we're getting some nulls is that our last read is going to be a buffer that's not complete, so we're going to have some zeros at the end of the buffer. So let's also try to log the buffers and see if we could get to that last log. Well, the last buffer is just 0 because we're not reading anything in that last read. But also, if you take a look at the buffer before it, we're having some zeros at the end of the buffer, which is not really indicated here because we're just logging some of the elements. But if we try to maybe log this element, maybe at location this, you can notice that even in our last buffer, we get some zeros. So what we can do is to remove those zeros from our buffer so that we don't get this weird null characters. So what we can do is to add an if statement. Now, if I log this read result again, if you take a look, we can check this bytes read property and see if it's not this value, which is the value of our buffer, it means that we have some zeros at the end of the buffer. So we need to remove those zeros so that we don't get those null characters. So let's try this one. So let's check this bytes read. So I'm going to say if bytes read is not equal to 16, what was the number? I'm just going to copy it. If the bytes read is not equal to this number, now what we're going to do is to first get the index of not filled. So we're going to get the index of the last element that's not filled, actually the first element that's not filled in our buffer. And the way we can do it is to say read result dot buffer, so this is our buffer now, dot index of 0, and this will return the first 0, the index of the first 0 that happens in our buffer. And now we're going to create a new buffer. I'm going to say buffer dot alloc. Now the size should be this one, index not filled, and now we need to do a copy in these buffers. So I'm going to say read result dot buffer dot copy. So it means to copy this buffer to a destination. So whatever I specify here is going to be my destination. So it's going to be new buffer, and then I'm going to specify a 0, which is going to be target start, which is going to be 0, source start, which is definitely going to be 0, and then source end. Now source end is going to be this index not filled. So I'm just going to write that in. So using this copy operation, we're copying this buffer to this new buffer that we just allocated with the right size, which is the size of those filled elements. So we're dismissing all these zeros, and we're copying that buffer over to this new buffer from these locations So we're starting from 0 all the way until index of not failed. And then we're going to do our write. So dest file.write new buff. We're not going to write that buffer that came out. We're just going to write the new buffer that we just created. And else, and our else statements, we're going to do our normal write, where our bytes read is equal to the size of that buffer that's going to get returned. Now if we run this code, well, looks like we have a typo somewhere. So here it's called new buffer. So I'm just going to paste that in. It was called new buff, so it should be new buffer. If I try it, so we didn't get an error, which is a good point. And if we take a look at our copy, now we can see that we got rid of those null characters. And we're just doing our copy with no problem whatsoever. Great. Now let's also try it with that text big file. Now this one took 9 milliseconds. And I'm also going to indicate the file size. So file size copied was 1 gigabyte, right? Yeah, it was 1 gigabyte. So let's try the same thing with our little streaming thing that we set up. So I'm going to copy text big.txt. I'll just confirm that the file size is 1 gigabyte. Yeah, it is. So I'm going to save, run the code. Now will take a while. Well, it took around 2 seconds, but let's see if it was successful. I definitely can't open it, but if we take a look at the file sizes, so text copy is now 1 gigabyte. So we copied this text big over to this text copy, and if you take a look at the file sizes, they do match up. But what we did is that we significantly reduced our memory usage. So let's try it again and take a look at our memory usage. You can see that it's around 20 megabytes, and it doesn't really go above that point. We're not sure because it exits quite fast, but it's around that. Now let's also try it with text gigantic. So gigantic. Now notice that actually this took 2 seconds. So let me just add these in. So copy it is 1 gig, memory usage around 20 megabytes, or let's just say 30 megabytes, and execution time was 2 seconds. Now it's definitely slower than this solution because here we're moving all the file in our memory and then we're just doing one write. So it's quite fast, but the memory usage is really awful. But here we're doing multiple writes. We have set it up as stream, but well, our memory usage is significantly lower and we're not limited to the file size. I mean, we could do this on a file that's like 1 terabyte in size, 100 gigs, it doesn't really matter. So let's also try it with text gigantic and see if it works, or see if we're going to get an error. Well, it's definitely going to take a while, but memory usage is around 30 megabytes and it doesn't really go higher than that. And my disk usage, yeah, bytes read 6. If it gets to 10, we're done. Let's also take a look again at the memory. So it's around 36 megabytes, 30 megabytes, I should say. And we're done. So let's take a look at the file sizes. The text gigantic is 10 gigabytes and text copy is also 10.9 gigabytes. So we are copying the file correctly without any issues. All right, so this little code here, as you can see, is a little streaming thing that we set up. So we keep reading from a source and we keep getting the chunks and then we write them to a destination. Now technically we don't have a buffer that we put the data in and then we pull it out, but you can imagine that this is somehow similar to that streaming thing that we did. Now let's also try this but using streams. I'm first going to copy this code and paste it, and also I have to comment it out. So we're getting our source file. It should be text. Let's first try with text big and then text copy. Now we don't need any of this logic. Instead we need to create our read stream and our write stream. So read stream equals wait, actually just source file dot create read stream, and const write stream equals, now this is going to be where we are copying our file in, so it's going to be dest file dot create write stream. Alright, so with these two in place, now rather than trying to use the data events on this read stream and get the chunks and then write them to the write stream, and also handle the draining and pausing and resuming this read stream, what I'm going to do is to just use something that Node.js already gives us, which is piping, which just does the same thing that we talked about. It will read from the source and it will write to a source, and it will automatically handle all these back pressuring, all these draining and resuming and pausing. So when using pipe, let me just show you how it works. So you just put in your read stream first and you call the pipe method on it. And for the destination, you have to specify a writable stream. You cannot specify a readable stream. It has to be writable. Now you could also specify a duplex stream and a transform stream, which they both also implement a writable stream, but the point is it should be a writable stream. And if you put a readable stream in the pipe destination, it's not going to work. So I'm going to say write stream. So what happens here is that this is read stream. So this pipe method will automatically read from the stream, and those chunks that it gets, it's going to write them to this destination. Now you could also chain these pipe methods like this and then put another writable like this, or another duplex or another transform, and then keep piping like this. So if you're doing this again, if you want to chain, you can't do it this way because this writable is just a writable. This should return a readable stream. So if you want to do this, these streams that you have in the middle, they should be transform or duplex, which they both implement a writable and also a readable. So I can't put a write stream here. It's going to return an error because there's nothing to read from a write stream, only to write to. So let's just quickly run this code and do a quick benchmark. So I'm going to copy our previous solution and just paste it here. So file size is the exact same file size, it's text big. Memory usage, let's take a look at that, and also execution time. So I'm going to say node copy.js, and we're done. So it took around half a second, which is faster than our previous solution, our streaming thing that we set up. And the memory usage should be fairly low. So if I try to copy it a couple of times, now in this case it's actually way faster. It looks like that my computer was just freeze for a couple milliseconds. It's actually 5 milliseconds, 30 milliseconds, which is way faster than what we were hoping for, right? Now, sometimes it gets a bit higher. Well, it really depends on a lot of things. I mean, what's going on in my computer. So results vary, but you could say that it's pretty fast. Sometimes we get to 5 milliseconds. Let me just delete the file and try it again. So I'm gonna delete, and let's try with text gigantic. So text big, gigantic, activity monitor, and if I run it, well, it was, well, actually it looks like our timing function is not right. And yep, it is not right because we need to do a callback function on this pipe. Take another look. Now let's also first make sure that it works, and then we're going to handle that callback thing. So we can't say for sure how much is the execution time because we need to see when this piping is done. There are various things we can do, so we're going to talk about them. And if we take a look at text copy, sizes, yep, they do match up. So here it's 411 and it ends here with 411, and they were both 10.9 gigabytes. Cool. So you can now come to the documentation and read the pipe thing. Piping is kind of easy to understand, nothing too crazy is going on. Well, it might look like magic, but at the end of the day, what's happening really is those things that we did previously. So it just handles these drainings and pausings and resumings for you behind the scenes. So here you could see that readable.unpipe. You could also unpipe maybe after a while. There could be some cases that you might want to do that. And here's how you could chain. And let's see. Now we could use this on.end on our readable to figure out when it's ended. And there we could run our time end function. So let's do that. So read stream.onEnd. And here I'm going to move in my time end function, and let's try it with text big just to be able to compare it to our previous solution here. So I'm going to run it. And well, it took around 1 second. So not that much faster comparing to our previous solution. But yeah, it's twice as fast. That's something. So I'm not saying it's our previous solution is better. Definitely not this one. Don't try this in production. Definitely make use of these things that are already built for you. There's a lot of care going on behind them, and a lot of good people are working behind them. So always using something that is there could be better. Not always, but in a lot of cases. So execution time is around 1 second, I guess. It varies, but that's about it. I notice it's not 5 milliseconds as we saw previously, was because we had this time end function somewhere that was not correct. So it will take a while to complete. So I'm going to just change it to 1 second, file size copied 1 GB, and memory usage is the same. Is it the same? Let's try it. Well, it could be maybe a little bit lower. 20. I guess sometimes it gets to 30, but yeah, let's just leave it at that. Let's leave it at 30 megabytes, just like before. It could be maybe a little bit lower, but a couple bytes really doesn't matter. So here's the definition of this pipe. You specify your destination, and it always have to be a writable. And you could only execute this pipe on a readable. You cannot execute it on a writable stream. And here we could see at the last sentence that the flow of data will be automatically managed so that the destination is not overwhelmed by a faster readable stream. So this is what we talked about, that the Node.js will automatically handle those things for you. And here we could see allowing chain of pipes if it's duplex or transform. So you could chain these methods like here. Now this Z should be a transform or a duplex. Let's see its definition. It's this one, zlib.createZip, well, which is a transform stream. So it makes sense. And this is how we can be notified that the piping was done. By default, stream.end is called on the destination writable when the source emits end. So this is how you can figure out whether or not the stream is done. And yeah, that's pretty much it. So let's take a look at the other things about pipe. And also, I just want to say this again. We talked about this choosing one API style, and we talked about this data events and readable events, but also piping is in this one of these API styles. So if you run this on data on a readable stream, do not try to pipe it again or use this unreadable. Just stick with one, and that's it. Don't try a couple things at the same time. It will lead to some unintuitive behavior, as it says here in the documentation. And here we can read more about these states, that if there's a pipe destination and if you remove them, what's going to happen is that I think this state will be changed to paused. Yeah, it will be changed to paused if you remove one of these piping destinations from a readable stream. So as soon as you add this, so I want to just do a quick recap. When we create our stream up until this point, this is not doing anything. It's not reading from the underlying resource. It's not giving us any data whatsoever. It's just sitting there and nothing is happening. And if I log that variable, which was read stream dot readable flowing, yep, that's it. If I log this and run it, you can see that now it's null because we're not doing anything. But as soon as I start piping, it will be true. And if I unpipe, so I'm going to say read stream dot unpipe and then log this again. Now we get null. Now null is our first log. Now at this point we are not doing anything with our read stream. Now at this point we start to read from it, so this property will be changed to true, which as you can see here. And right after, we're going to unpipe. So we're going to remove the destination and we're going to change the read stream into pause state again. So now our readable flowing value is false. If I start to pipe again and log this again, now it will be null, false, null, true, false, and then true, because we started to pipe this stream again. And here's our final file. So if you pipe and unpipe, it will resume from where it was paused. And to really demonstrate it, start with a text small. Let's run it. Now we're doing a couple of piping and unpiping like here. So we were doing an unpipe. If I run it, it's quite fast. And if you take a look at text copy, starts at 0, goes all the way up to 6 nines. So by piping and unpiping, that's how you can pause and resume reading from this read stream. You could also get this unpipe event. You can read the definition here. The unpipe event is emitted when stream.unpipe method is called on a readable stream. So here when we were calling it, we could also make use of that unpipe method on our writable stream. There's some more methods that you could just take a look here and understand easily what they do. And we also have this pipe event on a writable stream, which will be emitted when we call this stream.pipe on a readable stream, and we add that writer to its destination. And here, it's just at the beginning of the Node.js documentation, here it says a key goal of the stream API, particularly stream.pipe method, is to limit the buffering of data to acceptable levels such that sources and destinations of differing speeds, so we could have a source that's faster than a destination. So the key goal of streams is to make it so that we're not overwhelming our available memory, especially the stream.pipe. That's what this method is doing. All right. Now in production, you shouldn't really try to use pipe, and the reason is because of the poor error handling that you have available. I mean, technically you could do some error handlings, but you have to keep running the .on each one of these streams and then manually destroy your write streams if an error happens. Now what you can do instead is to use a pipeline. So I'm going to show you the documentation first. Here you could see the pipeline method, and you have to include it first, and here's the only place that it was mentioned in the documentation. It's way better than piping. Well, it's actually basically just doing the piping for you, but it will also handle the error handling for you, and it will destroy those streams if an error happens. So you could read the documentation that says a module method to pipe between streams and generates forwarding errors and properly cleaning up, which is very, very important. And we get all of this happens in the callback when the pipeline is complete. So if in production you just run this piping and you leave the streams as be, and some errors might happen, and actually they happen quite often. Your files might just get removed for whatever reason. Something might happen in your system, and maybe you're just dealing with a network, and your network might just go down for a couple seconds, or just for a couple of milliseconds, or a couple of microseconds. So errors do happen quite often in production, and using piping is not really recommended, because in that case you're leaving a lot of streams open and you're going to run into some memory leaks and memory issues. So always clean up when you do have an error. So you can just use pipeline and automatically let Node handle those things for you. This was recently introduced, I think it was version 10. And prior to this pipeline that it was introduced, we were using something like pump. Yeah, if I remember that correctly. So pump, this was a package that we're using to handle these errors, and you can see it was published 5 years ago. So if you scroll down, you can see that when using standard source.pipe destination, source will not be destroyed if dest emits close or an error. And you are also not able to provide a callback to tell when the pipe has finished. Well, technically you can use the end event, but yeah, it's right, you cannot use a callback to indicate that. But pump does these two things for you, so it will automatically destroy the source for you. And you can see it's a very quite popular package, 20 million downloads weekly. So when you want to use pipe, you should really take this into account and install this package instead of just using pipe, because you can see it's a fairly simple package. All it does is that you call this and you specify your source, transform, another source, and destination. Just like a pipe, the syntax is quite different, but you also get a callback function, and you could also, and it will also automatically destroy the source for you if one of these emits an error event. So this is what you should do if you want to use pipe, or just this pipeline. Now let's also take a look at the pipeline. Pipeline and pump, they fairly work in the same way. So I'm going to use this, and here we could see that stream pipeline will call the destroy method, which is really important. When you're done, you should destroy your methods. Now if it's successful, it will automatically be destroyed for you. So when it emits a close event, maybe a read stream or write stream, and then it's done, it will automatically be destroyed. But if it's not successful, it will not happen, but pipeline will handle that for you. So that's something else to keep in mind in our previous codes that we wrote. You have to keep in mind that if something happens, you have to manually destroy your stream. Now if it's all successful, it will be automatically destroyed for you, but if it's not, you have to take that into account. So maybe add in stream.onError and then manually destroy your stream. But anyway, let's include that pipeline first. So I'm going to say const, was it lowercase or uppercase? Lowercase. So pipeline require stream. And notice we actually haven't really used this module in this video so far, and it's because these streams that we used, like create read stream, are inheriting from this node stream module behind the scene. So if you take a look at the source code, you will see that they are inheriting from this. So if you want to implement your own streams, which is something that we're going to get into in just a minute, you have to include the stream. Maybe if you want to create a readable stream, you have to include the readable and then inherit from this readable, which is something that we're going to see in just a minute. But yeah, this is the module. We forgot to talk about it until this point, but we're going to see this module a lot more from now on in the video. So let's just use pipeline. I'm going to comment all these out. All you have to do is just call the function, specify your source, which is read stream, and just chain. You can add in as many streams as you want here, but you have to make sure that these streams that come in the middle they should be either duplex or transfer. You cannot put a writable stream here, because if you do, it will try to read from this and write to this, which is not going to happen. Or if you try to put a readable stream here, now this works fine from S2 to S3, but from S1 to S2, it will not work because it's a readable stream and you cannot write to it. So that's something to keep in mind. So let's try this and our error. You could also use it like a promise, so you have to include it from this. So node stream / promises, just like this file system module that we did. But I'm going to stick with callback right now. So I'm going to just log the error. All right, let's run it. And also let's move our time end log here. And well, cool. So you can see, well, we get undefined because we don't have an error right now. So you could just say if error, do something with the error, and if not, just log that the pipeline was finished. But this will now handle all those cleaning ups for you. So if something goes wrong here, it will destroy those streams and you're good to go. You could also use pump, which is quite popular and quite light. I encourage you to always take a look at the source code, at the GitHub account, and see what's going on. So you always go to the issues and always take a look at the source code. So we can see that the last commit was 2 years ago, which is not really that bad because, well, it's now really stable. It was published many years ago, 5 years ago, so really a lot of bugs are fixed. But the source code is quite simple. It's just one index.js file, and yep, it's really simple. So we have some of those destroying things going on around. Destroyer, we have this destroyer function which destroys this stream, and if you just search more, you could see that if something happens, it's going to destroy these streams for you automatically, as you can see here. So something else to keep in mind. Now, something else that I forgot to say, another useful function you can use for error handling and cleaning up is this finished function. So using this one, whenever a stream is no longer readable or writable or has got an error or was closed unexpectedly, you can use this function to handle your errors and do all the cleanings, as you can see here. So it's also something else to keep in mind when you are working with streams in production. Error handling and cleaning up is very important when you're dealing with the streams. So do keep in mind this pipeline function and also this finished function. And also this pump. Alright, so that's all that we need to know about piping. Definitely always check the documentation. I don't mention all of the things, that way the video would be really long, but we covered the core concepts, so you should now feel free and feel really comfortable to just come to the documentation, read everywhere that we have this pipeline, piping, read stream, write stream, and we're pretty much done with these sections. Now, we have to talk about a duplex stream and a transform stream. We just mentioned that a duplex is a stream that you can write to and read from, and a transform is a stream that will, just like a duplex, so it's inheriting from duplex, but it's also transforming the data somewhat somehow. But we're not going to use these two right now, just like we did here. We're not going to use the API consumers because honestly there's only just the Zlib and Crypto modules that use these two. So the FS module is not really using the duplex and transform, but what we're going to do is to implement them ourselves. So we're going to include them and then inherit from them. So we're going to move on to the next portion of the documentation. So API for stream consumers, this is how you could use a stream that's already written for you, be it in the Node.js documentation or a package that you install that will give you some streams. And the next API is how to implement your own streams. So we're going to first learn how to implement our own writable stream and then readable, and then we're going to learn how to implement a duplex and a transform, and then learn how to use a transform and a duplex stream by learning how to use our own streams that we created. And so now let's move on to this section. Alright, so now let's talk about how we can implement our own writable streams. So I'm going to close all these open files, and I'm going to create a new directory here, and I want to call it a custom writable. And instead of it, I'm going to create a new file called custom writable.js. And just to be consistent, let's just change its name to use a dash instead of a camel case. So like this. All right. Now, the way that you can implement your own stream is first by including that stream that you want to implement. So in this case, we're trying to implement a writable stream, so we have to include the writable stream, and it's capital W, from that stream module. So node.fs, node stream, like so. Now we have 4 streams available. We have readable, we have writable, and we have duplex, and we also have transfer. So we're going to use all these and implement our own streams, but right now let's focus on the writable stream. So you first have to include that particular stream that you want to implement, and then you have to create your own class. Now, if you're not familiar with JavaScript classes, please pause the video right now and go and learn how they work. It's really important to understand that. And if you don't know JavaScript classes, it's still fine as long as you understand JavaScript object prototypal inheritance. That's all you need to know. Now we're going to use a class syntax, which is just a syntactic sugar for that object prototypal inheritance. Now if you go to the implementation section, you usually see that, if I can find something here, you see the example first using a class and also without using ES6 features. So you could also implement your own streams just by using normal JavaScript. So you first have to define your function and then make it inherit from this writable that you're going to include. So we have both options. In this video, we're going to focus on the class-based syntax, but feel free to use this one if you feel more comfortable with this one. It doesn't really matter. So I'm going to define my class, and I'm just going to call it simply WriteStream, which extends or inherits from that writable object that we included right here. So now that we've defined our class, what we need to do is to call the parent constructor. So we need to use this super function. Now if you're using pre-ES6 syntax, it just means that in your function you need to call the writable object that you just created. So you need to call it and pass this, which refers to this function, to that writable constructor. So this is basically all that this super does. It just calls the parent constructor and passes this to that. So when you use .call, what you're doing is that you are saying that change the this difference of that function to this reference. It is really something related to JavaScript and will take a while to explain, so I'm not going to do it. So if you are not really understanding this part, just read about super and this, and you're going to be good to go. Alright, so I'm going to define my constructor, and I'm going to accept some options. Now in this stream, what we're going to do is to just implement that fs create write stream that we just did. So just to make it more easier to understand, I'm going to change it to fs file write stream. So we're going to create this stream, and then just like before, here in our write many code, we should be able to use it like this. So we should be able to call .write, .end, use the drain event, and so on and so forth. But now we have more control over how our object works. So what we need to pass is one high watermark value. I could also not pass it, and the default one would be that 16 kilobytes, but let's just do it. And also a file name, because we're going to specify what this stream should write to. Now in the constructor, I'm going to call that super function, and rather than just passing all the options that are passed to the constructor, what would be better is to just specify specifically what we want to pass to our parent constructor. And if we want to take a look and see what are all the options that you could use, you could see them all right here. So you could use this high watermark value, you could use default encoding, object mode, emit, close or not, and a couple more. So if you want to see the complete options, take a look at this portion of the documentation. So now in this case, I'm just going to specify the high watermark value, and that's it. Now let's also save the file name. So this dot file name equals file name, and let's now open the file up first before we try to write to it. All right. When you're implementing your own streams, you first have to, well, do this inheritance and then set up your constructor. But after you do these two things, there are some specific methods that you have to implement. And you could see the list right here. They must implement one or more specific methods. If you want to implement a writable stream, for example, you have to implement maybe write or write-en, or maybe both, and also the final, which is for our final write. Now for reading, you only have to implement this read. You cannot implement this read when you are implementing a writable stream. And for duplex, you have to specify all of these, but we're now focusing just on the writable stream. So you have to first implement this write method, which will be called whenever you write stream.write, and that's it. So if I initialize my stream here, so I say const stream equals new file write stream like this, and I could optionally pass my high watermark value, or I could just not, and default will be 16 kilobytes, and I'm just going to specify maybe 1800 like so. Now just like before, we could write to our stream like this, so stream.write and then our chunk, so we could say buffer.from whatever, so this is some string, and then we could say stream.end, maybe this, actually buffer.from our last write, like so. So when we do this, when we write to our stream, this method here will be called write. Now this method accepts 3 arguments. One is the chunk that we're writing, another one is encoding, which if we don't specify, it's going to be a buffer by default, and the last one, and which is quite important, is our callback. So here we're going to do our write operation, and then when we're done, we have to call the callback function. So when we're done, we should call the callback function. Now the callback will accept only one parameter, which is either an error or just null. So if you don't specify anything and just call the callback, it indicates that you are done writing and it should move on. Now when you run this write and then you immediately do another write, now while this is happening, so before you call the callback, it's going to buffer the data. So when I do double writes and I don't let this write to finish, and that means not getting to the callback, it's going to buffer. But if it does get to the callback and then I write again, it's not going to buffer. So if I maybe put this callback in a set timeout function, and that's going to write maybe after 5 seconds, and that 5 seconds until I call this callback, all the things that I write to my stream is going to be buffered. So when we invoke this callback function, what's going to happen is that we're going to get that drain event on our data, on our stream, excuse me. All right, actually drain. So when you call this callback, what's going to happen is that Node.js might emit a drain event for you. Now, one thing that I really want to make a huge emphasis on is that you should never ever emit these events from your child classes. So I shouldn't ever do this. So say this.event, maybe error or drain or things like that. You shouldn't do this at all right? If you do this, you're going to run into some issues. So never ever emit events from your child classes. Let the methods do those things. For example, here when you call this callback, it's going to emit this drain event for you, and you shouldn't do this explicitly. Now the same is true about overriding these methods. So you shouldn't really just say write like this and then overwrite the original method. Instead, you should use _write. Okay, so this is how Node will be notified that this is going to be your implementation for write. Never ever do this. Okay, this is really bad practice, and I don't even know that it's going to work. So it's really advised against in the Node.js documentation, so do not do this. And also one more thing, do not try to call these methods explicitly in your code, so never do this. Okay, it's again super bad and it's not really advised. You should just use those methods that you have available when you were talking about those stream consuming, and do not ever try to call these explicitly in your code when you're using your streams. Just use it as you would with any other normally stream object. So a couple points that I wanted to put an emphasis on. Now let's try to do our write. Now before we do our write, there is one more method that we can implement, which is called construct, which has a callback. Now this is a pretty important method, and this will run after your constructor runs and before the stream gets to the write method or any other methods that you are going to implement, such as the final and destroy. We're going to implement these in just a minute. So this construct will run after your constructor is complete and before you call this callback. So if I do a set timeout, and in that set timeout I'll call this callback, and the set timeout might have this 5 seconds duration. So what's going to happen in this case is that this write is not going to happen after 5 seconds. So this will call my constructor, and then after my constructor is done, my construct method will kick in. Now, until I execute this callback, all the other methods will be paused. Now, some of the things that you can do in the construct method would be initializing your data, maybe opening a file or opening a resource or whatever, and also do some asynchronous code. So let's try to open the file that we're trying to write to here in the construct method. So I'm going to first include the fs module, so const fs equals require node.fs, and we're going to use the callback version. So I'm going to say fs.open. I'm going to first specify my file name, which is right here, and the flag, which is going to be w, and my callback function. So we're going to have an error and our file descriptor, which is just a number, and we need to use this file descriptor later on when we want to write to our file or read from it. Actually, in this case, we're only going to write, but also when we want to close a file, we have to use this file descriptor. So when we open our file, what we're going to do is to first check for error. If we have an error, we're going to call the callback function and pass the first parameter to be that error object. So if you just call this callback and don't pass anything, it will indicate that the construct was successful and we will move on with our rest of the code. But if you do pass an error to it, the stream object will automatically handle that for you and exit the stream and indicate that, hey, we have an error, we cannot construct our stream. So else, if we do not have an error, what we're going to do is to save this fd variable to our stream object, because we're going to need to use it in all the other methods. So I'm going to define a new variable here, so this.fd, and I'm going to initialize it to null, because when we were just starting out, we don't have a file descriptor, but when we get to this point, we will have a file descriptor, given the fact, of course, that our open was successful. So this.fd equals that fd. And then when we're done, we're going to execute the callback like this. So I'm going to write some comments here. This will run after the constructor, and it will put off all the other methods until, say, it will put off calling all the other methods until we call the callback function. And here I'm going to say no argument means it was successful. And if we do pass an argument, it means that we did have an error. So if we have an argument, or if we call the callback with an argument, means that we have an error and we should not proceed. All right. So this is our construct method, and now in our write method, let's just call the file descriptor and see what we have. All right, so this.fd, and it's not a function, so let's just log it. So console.log this.fd, and let's also comment out these final and destroy. Just write to it once and see if we could get the file descriptor. So I'm going to open up my terminal. I'm going to navigate to custom-writable, and I'm going to run the code. And it looks like we have an error. Let's see what the error is. Path arguments. Well, yep, we're not passing a file name to it. So let's do that. So file name should be, let's also create a file, and I'm going to call it text.txt. So this is going to be the file that we're going to write on. So file name text.txt. All right. Now let me run it again. And now we do get our file descriptor, which is, as I said before, is just a number. Now in our write, what we can do is to just write to that file. Now notice that if we do this, it's not really going to be helpful at all. I mean, it's just like that first solution that we wrote right here, right?